From the average at-home chef to top chefs around the world, cast iron skillets are an essential tool for anyone's kitchen. Cast iron skillets have been used for hundreds of years and became especially popular in the 19th century, but what makes them so special? An iron alloy containing approximately 4% carbon and 2% silicon, cast iron skillets contain spherical graphite nodules which stop cracks from progressing, making them especially durable. Cast iron skillets are praised for their heat retention, even heat distribution, non-stick surface when properly cared for, and ability to withstand high cooking temperatures. Cast iron can be cheaply produced with minimum tooling in a wide variety of shapes including Dutch ovens, waffle irons, and corn-shaped muffin pans. Lastly, due to the alloy's high heat capacity, it is slow to heat up, but once hot, a cast iron pan usually contains more thermal energy than other pans at the same temperature, giving it a significant cooking advantage. Lodge, one of America's oldest cast iron cookware producers, have been making cast iron cookware for over 100 years. The ingredients that go into their cast iron skillets are pig iron, which is a high carbon content metal, recycled steel, leftover castings, and additional elements in small quantities called tramp elements. These ingredients are melted down at 1540 degrees Celsius, more than double the temperature of the hottest lava. The temperature of the molten metal is crucial for processing. Cast iron skillets, believe it or not, are made via metal casting, and more often than not, sand casting. If the molten metal is too cool, it will solidify before it has completely filled the sand mold. Too hot, and the molten metal will burn into the sand. Pouring the molten metal between 1360 degrees and 1382 degrees Celsius is the optimal temperature range for the sand casting. In addition to pouring the metal at the right temperature, making the sand mold itself is a crucial step in the casting process. A mixture of sand, bentonite clay, and water is mixed together into a large mixing mold called a molar. The mixture is then compacted together into a dense mold which must withstand a pressure of 29 to 32 psi. Within this pressure range, the sand mold not only exhibits good enough permeability to allow the air within the mold to escape as the molten metal enters, but can withstand the stresses caused by the solidification of the molten metal. Since Lodge is a high production manufacturer, they do not make the sand molds by hand. Rather, a press and die are used to create the negative shape of the skillet. It is at this point in the process that the molten metal is poured into the mold. Once the metal has had sufficient time to cool, the sand castings are broken apart, the cast iron skillets are removed and are then placed on a conveyor belt. Moving along this conveyor belt, the cast iron skillets move through a sandblast chamber which cleans the surface of any remaining sand. The cast iron skillets go through a quick machining process to shave off any excess metal that may have been left over from the casting process. Lastly, the cast iron skillets are cleaned and the surface is treated with an oil to prevent corrosion. The cast iron skillets are now ready to be sold. There are a few processing factors that can affect the microstructure of the cast iron skillets. As mentioned before, the temperature of the molten metal at pouring is extremely important to producing quality cast iron skillets. However, in addition to the temperature, the rate at which the molten metal is poured can result in similar problems. Pouring the metal too slowly can result in the metal solidifying before it has reached all portions of the mold. Too quickly, and turbulence can be an issue. Turbulence is characterized by erratic variations in the magnitude and direction of the velocity throughout the fluid. This tends to accelerate the formation of metal oxides that become trapped during solidification and increase the rate at which the mold erodes. For these reasons, pouring the molten metal too quickly or too slowly should be avoided. Lastly, the composition of the metal has a large impact in how solidification occurs. Pure metals have a single solidification temperature, simplifying this step in the process. Alloyed metals, however, can be more complicated. Except for eutectic alloys, solidification for most alloys occur over a range of temperatures rather than at a single point. This results in one of the phases solidifying before the others. From this, we tend to see 1. Dendritic growth, where solid portions of dendrite structures from one phase trap small islands of liquid metal of another phase, and 2. An imbalance in composition between the metal that is solidified and the remaining molten metal. These solidification effects can be detrimental to the quality of the cast iron skillets and should be avoided if possible. The compositions of most cast irons are around the eutectic point, so it's crucial to get the amount of each element correct in order to avoid the effects of non-eutectic solidification. These issues of processing cast iron can potentially affect the performance and quality of these skillets. Deviation from the correct processing procedures can decrease the durability, strength, reusability, machinability, and castability of the cast iron skillets. Metal casting is widely used in industries to produce a variety of products including engine blocks, plumbing parts, electrical hardware, precision machinery, water hydrants, gears, and so much more. And although sand casting is the most efficient method for producing cast iron cookware, they're also possible to make through machining large metal billets and additive manufacturing, though both of these methods would be impractical due to the large amount of waste produced and a relatively slow manufacturing time. To conclude, please enjoy this short video featuring yours truly.